Okay, welcome and thank you for coming. Hope this will be interesting for you. And I assume that you all know what technical debt is, at least a little bit. So therefore I won't go into all the details. And I think that if you came to this talk, then probably you expected that this will be the day you learn how to completely eradicate all technical debts and never have them again. But I have news for you. Bad news. That's unfortunately impossible. You just cannot get rid of it. Every time you work, you produce new technical debt. That's the reality. So is it even worth trying? And I would say yes. And I'll show you tonight how to get this done. First of all, because of this, we do have constant technical debts. It's just unavoidable. Every time you work, you have to make like a trade-off. Do I favor quality or speed? And do I want to do the compromise for future maintainability or not? In this case, you usually do one time this and one time that. Okay. And in the sum, you'll have some technical debt and some things that you really worked well and look that it's well structured, it's well organized, it's maintainable, it's well documented and all of this. But in general, you can never fully avoid it because you're not working alone, unless for your private project, of course. So there's always somebody making decisions for you where you would say, no, but actually, well. So we have like different levels where this can occur. We have the micro level, which of course is in the code. And in the end, everything lands in the code. This is where the technical debt finally is. And we have the macro level, which influences this as well. And we will see how this happens. But if you look closer at it, technical debt is in the code, but it's actually not necessarily a technical decision. The decision comes from the business strategic side, where you decide, like, do we need to deliver something fast? Do we need to do more of this and less of that? And overall, this is the compromise that comes out of it. And therefore, it's more like a business strategic decision to accumulate or to endure the pain of technical debts instead of just always making sure you never have them. But let's say you run into the worst case. Okay, so you have the Super-GAU in German, or the nuclear crisis, right? So what happens? Usually there's somebody asking, who's at fault? In the best case, no one, because everybody is happy to have escaped the responsibility. In the worst case, all of us, because the boss is on to us and we can't escape. But is this actually useful? Is searching somebody who's at fault the thing we want to do? Is a witch hunt what we want to do? How does that help us? It costs time, it costs nerves, it costs motivation in people, and it costs time. It's not, maybe not the best way to spend time to look for somebody to blame. And in the end, very often we turn up with somebody who's maybe not that at fault, but who will burn at the stake for all of us. But how does that help us? Not at all. The solution to the problem at hand and a way to learn how to avoid it the next time is what we really want to do. So the learnings is kind of important because we should not be repeating our mistakes so many times, if possible. There are like 3 areas, I will go through it very quickly here, just to say code and architectural causes, project process management causes, and people and knowledge causes. Those 3 areas can cause a technical debt in the end. The most obvious, of course, is code and architecture. You see a lot of things here. This is also a handout, so I will not go through everything. But just to name a few, Insufficient testing and lack of documentation is, of course, the way how to not detect technical debt early enough. So you're like flying blind, know what you want. Ignoring code reviews goes in the same direction. So you have the chance to detect any technical debt really early by your peers, and you're not doing it, or you're not doing it correctly, more shallow, more superficially, then you will fly blind. The unresolved bugs is something special. We all know it. We have bugs that we accumulate in a way that we feel uncomfortable with, but we have to live with that balance between fixing something immediately and fixing it later. But if we just ignore them too often, they will come back to bite us. So that's another source of it. Yeah, the rest. You have surely already looked at it. Project and process management is also a source for technical debts that you can see when there's, for example, inadequate planning. Of course, the less efficient your planning is, the more likely you will cause problems in the end, and this will result somewhere in the code. Somewhere. Always. Like if you forego analysis and design, your architecture will not be as good as it could be and not as future-proof as it could be. Inevitable. Then you have like the scope creep, which is here with the changing requirements. Of course, like when you don't handle the change management properly with your customers, with your other stakeholders, with your boss, with everybody involved, then you will go into scope creep. You will end up with the requirements that you actually didn't want to do, and the requirements that you have in your task list are not going to be processed properly. This will then also go into like the area of lack of prioritization. Means that if you don't have a clear prioritization of your tasks throughout a sprint and throughout several sprints, you may not end up doing what you should be doing first, and then later you come back and think, oh, I should have done this first because now I created like this library myself instead of just downloading it if I had known. But all of this can happen, right? Poor communication, even though it's here on the project and process management, has to do with people, obviously, but it is also part of the project management to make sure that everybody knows what they're doing, everybody understands what they're doing, and everybody is aware of why they're doing it now and not later or earlier. And all of this can go into making problems later where you might have wanted to have this, like a requirement, a business value that was formulated into a story, but it wasn't done in a way where people actually understood it correctly, and then you have to like redo it, wasting time and resources for nothing. Then, as Mr. Sartre said, hell is other people. Yes, wouldn't it be nice to not have to deal with people in IT, right? Why? Isn't computers enough? But what should we do with other peoples other than making them our friends and team members? And I think that's kind of the key of this. Where do you think this will lead if you have problems there in the people management? Let's call it like this. So you may have a lack of experience because you don't share knowledge between the team members, for example. Or you don't have a possibility to educate them. You have low team performance, which may come from low motivation, low loyalty, low team coherence, low everything, frictions between persons or groups. All this can cause then also a lack of communication or another source for accumulating technical debt once more. Lack of ownership, like for example, not clearly defined roles, can also fall into this area where it's not clear who's responsible for it and therefore nobody takes care of it. And then it ends up with the poor guy who always does it in the end, and yeah, chaos. This may result in high turnover, which is kind of like also the contrary of building up knowledge and skills in the team. If you have a high turnover, that's not going to happen. And not adopting new practices is kind of like, for me, it's something clear, like when you're in informatics, you want to learn new stuff all the time. You're happy when there's new methodologies, you can learn new technologies, you can learn, but not everybody is like that. Some people are pretty happy with the things they were doing the last 20 years. That's how it is. The three areas that we just talked about, they influence the quality of the product, of your product, which is software, infrastructure, whatever it is. And there is an interdependency because everything affects each other. So we have the holy triangle here of quality with time, scope, and cost, which tells you that if you influence two of them, the third one will be influenced indirectly. You can try to control time, or scope, or cost, or two of them at the same time, but you can never control all three. So for example, if you have in a project more time and more cost, so you're given a higher budget, this can allow you to extend the scope. This could be cool, because maybe you can do the same things in less time, and maybe even with better quality, who knows. But what you cannot do is directly affect all three of them. The interdependency makes this even harder. So you think you can put more time and cost into it, but because of the causes here that influence this, it will be less effective. You get less out of it. Like the team performance that I talked about, for example, or the quality basically then of architecture or code is much less than what you expected. And so this is kind of an awareness thing where you have to know what comes out of it and what doesn't and why not. One thing you can do and should do is measure and monitor. It's not just about performance of the software itself, for example, but also how do you perform as a team. You can measure that. You can see, for example, how many tasks do we have? What is the volume of tasks? And then you can see, let's say, this is an extreme example, but let's say we have 30 tasks and they are done in 30 story points. That's kind of weird. So every task is just one story point? This cannot be. You may find this immediately, but it may slip because it's not 30 and 30, maybe it's 30 and 40, and then you just don't realize it and it slips you by. The smaller the difference between story points and tasks, the higher the probability that you've done something wrong. You didn't estimate well, or you have suddenly more tasks that went into a sprint, but nobody estimated them. And they're not properly handled inside of the sprint, or more probably that they should have been pushed to the next sprint instead. And this will show you how well the team understands the product. It will show you how well the team understands the requirements, how well the requirements are written, and how technically mature your team is. So you can get this out of the trend. Of course, this has to be observed over several months. It's not something you can see just today or end of this sprint. And then you will see if there's a trend up or down, there is something wrong, and we have to look into why that is. Second thing you can do is measure the maintainability. Very important, like the lead time from the new feature definition to the delivery of a feature and the maintainability of your product. This is kind of super important. But it's also easy to measure. You just have to do it properly, reporting properly, and then see the trend, is it going up or down. The mean time to repair, like when you see a bug and then until the moment it is actually fixed. This is interesting. Does this show that generally we use a lot of time, or is there a trend to make it even bigger over time, which is kind of showing technical debt problems. Then you have the maintainability or maintainable release rating, which shows you a ratio between those things like the MTTR, the fixes, the releases. Is it small? Is it big? Okay, here the difference is super big, but maybe that's explainable, or maybe it isn't. And that's what you should look at. And also then the trend again over several months, is it going up, is it going down? Bug rates, also super important, like to see, are we spending more time on bugs than features, like in the extreme, maybe? Or maybe it's just a trend that we see that features and bugs are kind of coming together too much, too close, and that's not a good sign. Then what can you do on the level of code architecture? Should you refactor? That's always the big question, right? Well, I think before you do that, just look at the other things, like updating libs, tools, that kind of stuff. Maybe language versions, right? Just do it regularly. Do it like 2 or 4 times a year. Don't do it just once a year or once every 2 years. The more frequently you update tools and libraries and that kind of stuff, the more you gain routine in doing so. You're less afraid of doing it, and you're getting faster and more adept. What I saw in some cases is that if you work with teams that don't like to update, after 2 years, they're just too afraid. They're going to say, oh, this is going to take 3 sprints. And you say, what? Just to update the library? What? But yeah, so do it often, then it becomes really easy. Then you can look at the code age, like pick out the oldest code you have. Does it need updating? Does it need refactoring? Right. The code by proximity updating is something interesting because you can look like, for example, you have loading an XML file. You look into the file that actually needs the code change. But then you look at 3 other files which are related and directly using this. Do they need updating as well? Does the code look fine? Because if I'm doing this, I can just quickly do updates there as well. I'm in the same topic, my mind is set to do this, and it'll be just so much easier to do. Then the obvious things is like small refactorings. Personally, I think, like I said with this proximity updating stuff, just do it often, like every sprint. There should be some allocation of time to do it, but don't do it randomly. Discuss it with the team, right? And make sure that you don't spend too much time. But if there's something small you can do at the same time, like documenting, simple thing. You're working on a class, just document it if it's not. The bigger refactorings, of course, have to be pushed back and planned properly. They may take a sprint, and if it takes longer, it's even worse, of course. But as it is, you may enter a new company and they have an old product and then they want to modernize it, let's say. Then you may need to do some refactoring. How do you do it? And then there's also those refactoring patterns like Strangler and BFF that you could use, which help you to go over a long time from the old system to the new system without breaking it. What you can't do, for example, most of the time is like have 2 teams. One works on the new product, one on the old product. And it's not possible. Very often you don't have the time and the budget for this. So the same people have to work like in the same environment. Then also you may have in very long refactorings, which take several months or even longer, the fact that you can't shut down the company, obviously, right? So you need to find out a way, how can I do new features and then keep the refactoring going at the same time. Very complex stuff, but it's doable. Then the most important thing, of course, is how do I sell this? Because you can't just go to your boss and say, hey, I need nicer code. It doesn't look cool. What do I do? Find arguments that interest the person you're talking to. So you have like different stakeholders. CTO, CEO, for example, have their own view on the company, on the team, on the product. Find arguments for them that speak to them, that make sense to them. And if you have numbers, I didn't put them in, right? But from your measurements, if you have numbers to show trends, to show, okay, this is costing us more, and if we do this, then it's costing us less. That's even better, right? Then you have like the project owner, project manager. What are they interested in? Like, right? Speed, of course, more features, that kind of stuff. Smooth sailing through the project. Then you have also developer. You're not just you yourself, but you're in a team. What are your peers interested in? Why should they be doing refactoring? Right. So find arguments by putting yourself in shoes of others. And then it's just so much easier to handle it, to sell it. And I think then also you can find, hopefully, can find with not too much resistance the time and budget to do it. Right, almost in time. Fortunately, I had to rush through it a little bit. I'm sorry, but you can look at the handout later in all details. So now I'd like to ask you, what is your experience with technical debt? What do you see as problems that arose from that, and how do you handle it?
Any questions or comments?
No one?
If not,
Nobody has ever encountered technical debt. That's wonderful.
We all have too much.
We all have too much. What does it mean you have too much?
No, I think in every.
I think you all know it, right? Every application comes with it, but
Yes.
just deal with it and make
How
sure
do you
there is
deal
not
with
too
it?
much. Constantly work on it.
You do that in your company?
Sure.
Like what, for example?
Like we know what are the more strategic things and the higher architectural blockers that you mentioned, and prioritize them accordingly, more on from a longer perspective. And on every sprint we have technical debt also coming in and
that's
working
great.
actively on it.
Yeah, very good.
Otherwise
You're
we
lucky.
pay it back with way more interest.
Yeah, exactly. It's really great. Does everybody have a company like that? Gives them so much time to work every sprint on it? Yeah? You look like maybe you have to say something about it. Yeah? Yeah, okay. Well, anyway, thank you very much then for listening, and have a good evening with the other speakers. Thank you.
Thank you.